the management attention graph look like? We know that if we release the material too early, that means the due date is far off, and if our calculation shows on an average the throughput time is, let's say, X days, and we release this material for production X plus 50% cushion, this is called early. Now we know that when we start releasing all the materials early, it is going to choke the production line. The inventories will rise. And when the inventories rise, the throughput time goes up. So I can't release the material too early. Too early is also giving me enough cushions for disruptions. And we all know Murphy exists. So Murphy is one of the drivers for the case to release the material early. Now sometimes it happens that the material release being early is not only from the point of view of meeting the due dates. Sometimes local efficiencies come into play. If your most important machine is lying vacant, you say, okay, let's produce it and keep it, because it is going to be used anytime. It may be used 2 days later, but since this machine is lying here not being used, why don't we use it? This is also early release. So we don't want to miss the due dates, and we know there's uncertainty in the process, or there's an instability in the system, or we talked about the 3 instabilities. So we put enough cushion on our approximate time the order will take to make, and we release the material. Now if there are too many of such orders in the pipeline, what happens on the shop floor? The priorities start changing, and to set the priorities, again a huge amount of management attention is required. But more than that, what happens is, what is the rule? The rule is, any order which is getting late, please make it first. So all the companies, or you will see a behavior that very few orders are out on time. You started by releasing the material early, expecting it to meet the due date, but more and more orders are not meeting the due dates. This is because there are so many conflicting priorities existing within the system that the throughput time goes up. And the throughput time goes up because the queue time goes up. The queue time goes up because you are changing priorities. So now you are releasing as well as the queue is going up, so more and more items flow onto the shop floor and it chokes more. Now this again requires huge amount of management attentions. But this is where we are seeing most of the people. That shop floors are constantly having meetings, constantly there is a report how many orders were on time, the customers are breathing down the neck. So this is a very real phenomenon which we are seeing in most of our shop floors. And that is why we also deploy a lot of people. This is nothing but management attention. This is on the one side. On the second side is, maybe I said, let me just release the material very, very close to the due date. That means if the dispatch date is, let us say, 20th of this month, and I know approximately it takes me 4 days to finish this whole batch, so I will release this material on the 16th. Now this is to say that if I release the material as late, I will not allow queuing to build up. And if queue doesn't build up, I am not going to increase the throughput time. That means my assumptions which I had started off with will hold. Now mind you, there is Murphy. It could be a quality problem or a machine breakdown or anything, and you will be left with a loss of sale because you were not able to produce it on time. The flow lines or the Kanban systems who carry very less, you can say, buffer or very less cushion in time, okay, perform on the other extreme of the management attention. This is another place where you will be constantly paranoid that what will go wrong, what will go wrong, what will go wrong, because you have removed all the cushions from the system. So the management attention is something like a U-curve. On one side, you have a high management attention because you took too much of cushion, and then again you have a high management attention because you have not given enough cushion. We can keep debating and also develop a sophisticated system to say that I will develop a mechanism which is going to optimize this. But then that is exactly what we don't want a system to be. A good system is a simple system. Simple system understood by everybody. So if we start using a management attention as one of the parameters to be satisfied, we can say that we don't want the extremes. We don't want too much of cushion. We don't want very less cushion. So what would be the adequate time? Now, when we started calculating the throughput time, it was based on the queues in the system. So our job is, if we remove the queues from the system, the throughput time should go down. We know we cannot remove all the queues, so we cannot go to the leftmost part, and we also cannot allow the old queues to exist, so we cannot go to the right hand part. So it's a very simple way of assuming that let us start with a time which is slightly more than the time required for it to be manufactured. Going back to what we said earlier, we know that for most production systems, the touch time, that means the time it takes for you to transform the material or to work on the material, is just 10% of the total throughput time. So, extending this further, if I assume that the current throughput times, which are the resultant of high queues in my system, if I slash it by 50%, it's a good enough thumb rule to work. Most of the companies have batching. What Ford and Taichi Ohno tried to prove was have a single piece flow. When you talk about a batch, even if you talk about a batch of 10, when the first one is working, the 10th one is waiting, right? Even though that the touch time of this system of 10 will be 10%. So any size of batch more than 10, the touch time should be only 10%. Unless you move to single piece flow, then the touch time will be equal to the throughput time. This was the aim of Ohno and Ford. Ohno managed the flow lines, but instead of one piece was able to systematically move towards one piece while reducing the numbers or reducing the Kanbans. Coming back, we know that if there is a batch, the touch time is only 10%. And from our experience, we know the throughput time. So very robust place to start is half the lead time that you currently experience. But even if I halve the lead time that I currently experience, am I subjecting myself to risk? What is the risk? The risk is of missing the due date. Am I really subjecting myself to risk? Let's go back and check. My previous touch time was 10%, 90% was queuing time. And I also know that if I am able to time the release better, the queue time will go down. The touch time cannot go down. If I assume that now the new throughput time is 50% of what was earlier, what I've got rid of? I've got rid of the queuing time. Touch time is still there. So now touch time becomes somewhere around 30% of the total throughput time. That means still there is a chance that a lot of my orders will be able to go through the system in the new calculated throughput time. So using management attention as one of the parameters to be satisfied, it is fair enough not to go into a systematic or a very high algorithm to set priorities. Okay, but we just find out that if we assume that queue is an important part of the throughput time and our system is going to chop this queue time, it is a very good approximation to begin by using half the current lead time as your throughput time and release the material that much of time before the due date onto the shop floor. By just allowing it to be on the shop floor for that much of time, you are reducing the queues. However, the algorithms that develop also focused on one more thing, which is called the priority. By just having selected the throughput time, you have not solved everything. You also need to focus or develop a small understanding or a small system or a rule how to prioritize. The priority system that should be in place should be easy and helpful in removing any conflicts. By now, we have reduced the throughput time, or we have assumed a throughput time of 50% of the current throughput time, and that is not off the cuff, it is after a lot of scientific understanding. By reducing the throughput time by half, technically we have reduced the inventory by half. We have made sure that a lot of orders are not on time, but Murphy is still there. It can happen that the orders are not on time. So we need to have a priority system which is going to flag all those items which need to be looked into.